Hey guys, Mr. Gibson here. So this video is simply going to go over the answers for the summary page to make sure we're all good to go and on the same page as far as orbital notation. Okay, so number one says, what does the Aufbau principle tell us about filling atomic orbitals? Well, it tells us that orbitals have to be filled in order from lowest energy level first, going to higher energy level. Okay, think of it like building a building. You wouldn't start building the fifth floor before you started building the foundation in the first floor. Okay, it would make sense. It would just collapse, right? So you would, same with electrons in orbitals. You must fill up energy level 1 first, and then energy level 2, which is S and P, and then energy level 3, and so on and so forth. Okay. Number 2, what does the Pauli exclusion principle tell us about filling atomic orbitals? Well, it tells us that one, that orbitals can only hold a maximum of 2 electrons. Okay, so each orbital holds 2 electrons, and the electrons in those orbitals must have opposite spin. That's why we draw them with arrows going in opposite directions. You would never draw 2 electrons in the same box or the same orbital with electrons going in the same direction. Okay. Number 3, what does Hund's rule tell us about filling atomic orbitals? Well, it says we have to fill orbitals with electrons of the same spin first. So, like for example, down here, you see with phosphorus, filling up 3p, we had 3 electrons left. So you put 1 in each orbital before you double back and fill in the other ones. You don't put 2 in the first one and then 1 in the second one. Okay. Electrons don't like being near each other. They're all negatively charged, and similar charges repel each other, right? So just like being on, think of it like being on a like a bus, and the empty seats are going to fill up first before anybody goes and just sits down next to a stranger, right? So same with electrons. You're going to fill up, or you're going to put 1 electron in each of the empty orbitals for a sublevel before you double back and start filling in the ones in the opposite direction. Okay, and that's Hund's rule. So number 4, which do we fill first? Low energy orbitals or high energy? Well, we're going to fill those low energy ones first. We got to fill from low to high. Okay. Then we have a periodic table below. And so certain sections of your periodic table will correspond to regions on the periodic table. Okay. So these first 2 columns in the periodic table correspond with the S sublevel. So all of the elements in these sections, in these columns, their last electron will go in the S sublevel. Okay, the purple over here, all of these correspond with P. The middle here, the transition metals, all correspond with D. And the ones that are at the bottom that technically fit in here between S and D in the last 2 rows that we draw below here, they're called the lanthanides and the actinides. They correspond with the F sublevel. So those are elements with whose electrons will be in the F sublevels at the end. Okay. Number 6, it says list 3 ways we can represent how electrons fill orbitals in an atom. Well, 1, we can do orbital notation, where you draw the boxes and the arrows. Or we could do the full electron configuration, where you write out each of the sublevels and you just write how many electrons are in each sublevel or each orbital. And then C, you can do noble gas electron configurations, where it's kind of abbreviated, and we use those for when it's like really long. We'll just write the nearest noble gas before it and then start where it would pick up after the electrons of that noble gas. Number 7 says write the orbital notation for the following elements. So here is the key. Here it says oxygen. So oxygen has, first thing you would do is you would find the number of electrons on the periodic table, which is just the atomic number. Okay, so oxygen has 8. So you would fill in 1s first. It has 2 there. Then once that's full, you go up to 2s, which has an up and a down electron, and it's full. And then you go to 2p. Now 2p is not going to fill all the way up. There's not enough electrons. So in order, you would fill, so it would go 1, 2, 3, 4, 5, going up, 6, 7. And then once you have an arrow in each of the boxes, you double back and do electron 8. And that's all the electrons oxygen has. So that is where we stop. Okay. Then you have carbon that only has 6 electrons, and there's its notation. You have phosphorus. Okay, phosphorus has 15 electrons, so it goes 1s, and you put 2 there, 2s, then 2p, and it fills up. Then you got to go on up to 3s, then 3p. Okay, and then down here we have germanium, which is rather large. Germanium has 32 electrons, so it goes 1s, and that fills up 2. So you go on to second energy level, where you have 2s and 2p. Those are filled up. Then you go to the third energy level, 3s, 3p, and then you actually go to 4s before you go to 3d. 4s's electrons actually have less energy than 3d. And I know that's kind of counterintuitive, and I'm sorry that that's the way it is, but that's actually how it is in real life, so that's how I have to teach it. Okay, so 4s is full, then you go to 3d, and then what's left, you go to 4p with 1 up arrow and 1 up arrow. Okay, I hope that's helpful. If you guys have any questions at all or need any help or want me to explain this anymore, feel free to email me, okay?